Welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a huge challenge for computers, understanding that a single word can have many meanings depending on the context. For example, in the sentence, "The traffic light turned yellow," the word "turned" means something very different than in "he turned in his homework." This problem is called word sense disambiguation, and getting it right is fundamental for creating smarter AI. Traditionally, there have been two main ways to tackle this. Symbolic AI uses strict, logical rules, which are precise, but brittle and can't handle the messiness of human language. Modern neural networks and LLMs are great with context, but are often a black box and lack structured reasoning. This paper proposes a hybrid approach to get the best of both worlds. Here's the clever four-step process the researchers designed. First, a symbolic system analyzes a sentence and generates a list of all possible, logically structured meanings for an ambiguous word. Second, it converts these complex logical forms into simple, plain English descriptions. For our turn example, one option might become "turn is a becoming," "traffic light is acted on," while another becomes "turn is a submitting." Third, it presents these plain English options to a large language model, or LLM, and asks it to pick the most appropriate one given the sentence's context. Finally, that choice is sent back to the symbolic system to lock in the correct, structured meaning. So, does it actually work? The researchers tested their system, called CNLU+54, against a standard BERT-based model on a set of sentences with ambiguous words. The results were impressive. At the coarse-grained level, just getting the general category right, their system achieved 84.2% accuracy, beating the baseline's 69.3%. But for fine-grained distinctions, the subtle differences in meaning, their system scored an amazing 82.5%, while the baseline struggled at just 20.2%. This shows the hybrid model is exceptionally good at understanding nuance. Of course, it's not perfect. The system sometimes made errors that defy common sense, for instance, confusing a building's window with a computer's display window in the sentence, "Vandals threw a rock at the window." This highlights that even powerful models can lack basic real-world understanding. So let's recap the key points. This research introduced a novel hybrid method that combines the structure of symbolic AI with the contextual flexibility of LLMs. Crucially, this approach doesn't require expensive, hand-annotated training data, making it far more scalable. It proved to be significantly more accurate than standard methods, especially at identifying subtle, fine-grained differences in meaning. This could pave the way for more sophisticated AI assistants, better machine translation, and systems that can genuinely reason about the language we use every day.